Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over another radioactive decay problem. And so in this problem we still have our 135 milligram sample of plutonium-236. And this time we want to know how long it's going to take for that 1.35 milligram sample of plutonium-236 to decay to 0.100 milligrams. Okay, so and we're given half-life of plutonium-236 is 2.86 years. So again, here we have our equations. Now, as I said before, we can use these two equations and use them together to figure out our sample, right? So you could figure out K by plugging in the half-life and then plug K into there to then solve this for the initial or for the amount after t. So we want to know, or I'm sorry, we want to find the time it takes t here. We want to know how long it takes for our original sample, 1.35, to decay to this sample. So we could do that, but we also have this equation here, right, that has basically these two put together, right? So I can solve uh, for k, and then I can substitute in whatever k is into here, and then rearrange this equation to get this one here. Now, I'm not going to do that in this video. I've done that in a previous video. So if you haven't seen that derivation and you're interested, please watch that video. Also, from this equation, you can get these two, right? So here, this equation solves for the amount after time t. But if the problem is asking for a fractional amount, what's the fractional amount after time t? Then all you do is divide both sides by n naught here, which is the initial amount, and you end up with the fractional amount equal to 1/2 raised to the power of the time elapsed divided by the half-life. And then, of course, if you want the percentage that's left, not the fractional amount that's left, but the percentage, all you do is you take the fractional amount multiplied by 100. So the percent left is going to be this same here multiplied by 100 to turn that fractional amount into a percent amount. Okay, so let's go ahead and use this equation here, and I'll show you how it's done. So we're given that the initial amount is 135 milligrams. And we want a final or amount after the time that has elapsed to be 0.100 milligrams. So what we do is we just plug everything into our equation. So the NT, I'll write it out here. So NT, this is the amount that remains after time t. And we were told that that's going to be 0.100 milligrams. So that's 0.100 milligrams. Our N naught or N0, it's referred to as N naught, which is the initial amount that we started with, which in this case is 1.35 milligrams. So N naught is equal to 1.35 milligrams. And we're told that our half-life is 2.86. So that's going to be T1/2 is the half-life, and that's 2.86 years. And we're looking for the time that elapsed. How long will it take for this decay to happen? That's T. We don't know. So now we just plug everything into our equation. So NT, which is 0.100, so 0.100 milligrams is equal to N naught, which is 1.35. So 1.35 milligrams multiplied by 1/2 raised to the fractional amount here. So we have t. T is what we're trying to find. So t divided by, oops. Sorry about that. So t we don't know, so that's t. The t1/2, our half-life is 2.86 years. So we're gonna put that here. 2.86 years. 2.86 years. So now all we need to do is solve for t. So the first thing we want to do is divide both sides by 1.35 milligrams. 1.35 milligrams. So this will cancel out. Here, milligrams will cancel out. And so then we get, we're going to calculate this out. So let me just calculate that out. Okay, and that's equal to 0.07. 0.070. Oops, nope. That would be 0.07407. I got a few more digits than I need, but that's okay. And that's going to be equal to now the 1/2 raised to t over 2.86 years. Now, here I have this as a fraction. This fraction is a power to 1/2. Now, I need to get this out of the power form. So how do I do that? I do that by taking the log. So I can take the log of both sides, and then that will allow me to, to do this, to get this to a, not as a power. I want to get it out of the power. So that's what I'm going to do. Okay. And so then I'll have log of 0.07407. That's going to be equal to the log of 1/2 raised to the power of t, that's a t, over 2.86 years. And so using our log rules, I can move this power down in front. So let me take the log of this. So the log of that is going to be, so 0.07407 log. And so I get a negative 1.130. So that's going to be a negative 1.1303. And that's equal, and then I can bring this power down in front here. So I get t over 2.86 years. And then again, that's going to be multiplied by the log of 1/2. But the log of 1/2 is a certain number. So I can now divide both sides by the log of 1/2. And the log of 1/2 is, if I do 1 divided by 2 equals, take the log of that, I get negative 0.3. So this here is a negative 0.30102. We'll just say 0.1. So I'm going to divide these two. And what I end up getting then is 0.1303 negative equals, I get 3.754. So this is going to be equal to, so this is going to be 3.754, 3.75477. So I got more digits there. Just carried more digits to avoid rounding mistakes. So now this here is equal to t over 2.86 years. And notice that this has no units, this has years. So if I'm going to now multiply both sides. So I multiply both sides by 2.86 years. This is now multiplied by 2.86 years. So this cancels out. Now I have t by itself. So now if I multiply this, I get 10.73 years is equal to t. So that is the answer. This is the amount of time it would take for my 1.35 milligram sample of plutonium-236 to decay to 0.1000 milligrams. And so that's how it's done, ladies and gentlemen. So if this was helpful in any way, if you enjoyed this video, please, by all means, like the video, share the video with your friends, hit that like button. Also, don't forget to subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.